In this video, we are going to learn about independent events. The standard that's covered is MGSE 9 through 12 SCP-2. So that's about conditional probabilities. We are going to understand that if two events A and B are independent, the probability of A and B occurring together is the product of their probabilities. And that if the probability of two events A and B occurring together is the product of their probabilities, the two events are independent. That if the probability of A, I'll write as P of A. Let me write P of A is the probability of A, and P of B is the probability of B, and P of A intersection B, that is, it is A and B, is the probability of both A and B. Now, if you multiply these two, the probability of A times the probability of B, the product of those two, if it is equal to the probability of A and B, in such case, we say that the two events A and B are independent. That is, if P of A and B is equal to P of A times P of B, then the two events are independent. And other way around, if you know that these events are independent, if A and B are independent events, then the probability of A times the probability of B is equal to probability of A and B. Now, let us look at an example. So before that, we need some basic vocabulary. So the first one, compound events. That is, whenever you have two or more events happening together, then you call it as a compound event. That is, more than one event that is taking place in that time. We can say that it's a compound event. In this case, A is one event and B is the other event. So more than one event. Hence, we have in this scenario, it is a compound event that is taking place. Now, like we said just now, the independent events are those. This is the mathematical formula. P of A times P of B equal to P of A intersection B. Now, what do you mean by the independent events? The events whose outcomes do not influence each other. That is, whatever is happening to the first event has nothing to do with the second event. Okay, now let us look at an example. Here we have two coins. And let us see what happens when you flip them. Now in the first case here, I got heads. Again you do it, you got tails. So there is equal possibility of getting either a heads or tails from the first coin. Now, is there any effect of this first coin on the second coin? Obviously no, there is no any effect. And here I am saying tails, and again when you do it, tails. Likewise, each time you flip the coin, you have even chance of getting either a heads or tails. So first coin can give you either heads or tails. In the same second coin also can give you either the heads or tails. So now we are putting those two events, these two things together. First coin's possible outcomes are either the heads or the tails. In the same way, from the second coin, the possible outcomes are either heads or tails. Now, the compound event is that we want to put those two flipping of the coins together into this. Alright, so what happens now? The first coin I'll write first. So first heads, and the second coin also gave you heads. I am combining these two. H and H I got here. Now in the same row again in this column, I'll write heads first. That is, the first coin gave me heads and the second coin is giving you tails. Okay, so we are done with this first row. Now come to the second row. In this, we observed, or we have written tails here. So the tail is the outcome from the first coin, and the heads H is the outcome from the second coin. And in the last cell we have T and T, tails from the first and tails from the second. So these four H, H, HT, TH and TT are the total possible outcomes from the first and second coin put together. The first letter is from the first coin and the second letter is from the second coin. Now that information obtained from the table will represent it in a Venn diagram. And now in this Venn diagram, I have a universal set. That's a U. It's a big rectangular box. And two circles we have representing two events A and B. Now the first event A is telling us that we have to take only that outcome where the first coin is landing on heads. So A is telling us that first coin is landing on heads, and B is telling us that the second coin is landing on heads. Okay, so we have to be careful as we transfer this info from the table into the Venn diagram. Now this first outcome H and H you have, that is the first coin is landing on the heads, second coin is also landing on heads. That is, it is fulfilling the first and the second conditions, both the conditions. Therefore, this HH will definitely come in the common region between the sets A and B. I'll write H and H here in the common area. Now, what about this HT? Heads on the first and tails on the second. That is, it is fulfilling the required condition for A, heads on the first. But is it fulfilling the condition for the second? No. So it belongs to only the set A. Therefore, this outcome HT comes in the area which is represented only by A. This HT is within this. First outcome, the first flip is heads, and the second coin gave you tails. Now going to the third, TH. Tails on the first, heads on the second. Tails on the first, so you don't go in A, but heads on the second, that is in the second set B. So I can write TH over here. So heads on the second, that's why it is here. If both are heads, I could have written in the common area. Alright, now going to the last piece, tails and tails. The first coin is landing on the tails, second is also landing on tails. So it is neither satisfying the first condition nor the second condition. So it is not fit either in the set A or in the set B. You cannot put in any of these two. Therefore, you have to place it outside A and B. So I can write this tails and tails anywhere outside AB. Now let us find the probability of these events happening or taking place in a given scenario, like flipping of two coins. Okay, now what is the total number of outcomes here? I have 1, 2, 3, 4. All together we have 4 outcomes. Now in this area, that is only set A, that is only the first coin landing on heads is taking place just one time. Okay, so I can write this piece as 1 out of 4, 1 out of 4, which is also 0.25. In decimal form, you can write it as 0.25. See, the total is 4, 1, 2, 3, 4. This is only one time I have there. I'll write 0.25. So 0.25 is the probability of this HT taking place. That is heads on the first coin and tails on the second. That is only 0.25 chance. In the same way, what is the probability of both the coins landing on heads, H and H? There is only one time it is taking place. So this also same thing, 0.25. I can write 0.25 here. And thirdly, TH. First coin tails and the second is heads. That also only one possibility is there, 1 out of 4. So it is 0.25. And the last one, both the coins landing on the tails T and T, that is also 1 out of total 4 from that. So it is 0.25. Now this Venn diagram, from Venn diagram you have obtained the probabilities of all these pieces separately. Now if you want to know the probability of A, like here this is A is the whole set, this whole set, this circle is A. Now what is the probability of A? That is equal to, I have to consider the whole set A, that is 0.25 in this area and again 0.25. So 0.25 plus 0.25, adding those two, you got 0.50. So the probability of this event A taking place is 0.5. Similarly, the second one, set B, the probability of this event B to take place, like landing on the heads in the second coin, that is second coin landing on heads is this 0.25 and 0.25. So probability of B is equal to 0.5, 0.50 or 0.5, just the same thing. Now this information, let us put it in that formula which we started at the beginning of this video, that we were talking about independent events. So we are verifying about those two events A and B, whether they are independent or not. So now we have the probability of A, that is P of A is equal to 0.5 and P of B is also 0.5. If you multiply those two probabilities, okay, what do we get on multiplication of those two? 0.5, let me put it here. Okay, so you have over here, let me cancel this. All right, P of A times P of B is equal to 0.5 times again 0.5, which is equal to 0.25. 5 times 5, 25, and decimal point is after 2 digits, so 0.25 you got. But here we can see that 0.25 is the probability of those two events A and B taking place. That is 0.25 is nothing but probability of A and B. P of A and B. So we are proving that this product, probability of A times the probability of B, is equal to the probability of A and B. That is P of A times P of B equal to P of A and B. Hence, these two events A and B are independent. This is how you can verify if the given two events are independent. Thanks for watching.